where he developed baseline scenarios for New York City neighborhoods by analyzing urban datasets. His work for the postdoctoral research scientist was within the Climate Change Science Center at the Oak Ridge National Laboratory, US, at the US Department of Energy, focused on data model integrations to understand climate change impacts on the Arctic ecosystems. Over the years, Sir has carried out extensive fieldwork in the Arctic, Antarctic, US Southwest Desert, and coastal India, totaling over several years of actual field presence. Without any further ado, I would like to hand over the session to Dr. Santanu Goswami.
Thank you very much. Thank you for the introduction. Excited to be here. Actually, I've been hearing about this initiative for a few months now, and so finally, I'm glad that I'm able to actually, talk to the community. So today, I'm going to talk about data-driven approaches in climate and environmental research. Before I start, I just want to give you a bit of a warning that this is not an AI talk. Okay, this is not an AI, ML, or deep learning type of talk. So here I wanted to share what we do in the climate and environmental research, because we have been using data extensively over the years. So we do data science, but ours is domain specific. We try to look into problems, we try to solve a problem, and we try to get as much help as we can from data. Along the way, we use a lot of data tools. We develop a lot of data tools, develop algorithms, and among those, these new sets of tools or approaches that we call machine learning or deep learning, basically advanced statistics, they also come along. But our goal isn't just to use those tools. We want to make sure that we want those tools to actually, help us get some solutions, so that some traditional tools may not give. So it's it's an overview of what we do, how data is creeping into environmental and climate research, and just to give overview of the field, and hopefully this triggers some interest in the young research community, and people show some interest in getting into this field. That's the idea. So before I start, this is something that you all see. I mean, it's a lot of basically warning, a lot of alarming news that we see in the newspapers, and these are some reactions of IPCC, Intergovernmental Panel on Climate Change report that came out last year and also this year. It's from last year. That triggered a lot of reaction in UK and then to the other parts of the world. And these are some of the actually news that you see here. In India also, this is when you talk about India and when you talk about climate change, the number one thing that we worry is the monsoon, because India, as a populous country, so we really need to worry about our agricultural productivity, and monsoon is something that drives this productivity as well. And because climate change is creating a lot of scenarios, droughts, floods, and disasters, like other disasters, those are coming along as well. So you can see some of these news I'm just highlighting out here, and also changes in temperature, which causes heat waves. It's also becoming alarming in our part of the world, and also in some other parts as well, right? So all these climate, this climate change and climate whatever is happening, it happens because of this famous effect called the greenhouse effect. Earth has a atmosphere around it, and it gets all the uh, gets all the basically energy from the sun, and because of the atmosphere, the sun uh, the earth traps some of the energy, which keeps the earth warm. But some gases that we have in the atmosphere, it's called greenhouse gases, such as carbon dioxide, water vapor, etc., etc. They can capture the heat, right? And those are, because those gases actually, our Earth is warm. But there is a balance to it, right? How much energy we get from Earth, how much we actually, gets reflected back, how much we get, basically keep for ourselves. With the increase of these greenhouse gases, this warming is becoming is more and more, and that's causing these worry, and that's causing all these changes because it's actually creating a lot of different changes, right? And this greenhouse effect uh, is leading to this climate change, and which is basically this greenhouse effect is the root cause of all the evil things that's happening on Earth currently, right? So we climate science is pretty hot right now. It's becoming very popular, mainly because we need to keep a lot of attention to it. But if we think about the history of climate science, it developed a long time ago, right? So when the discovery of the greenhouse gases, that it can trap heat, and basically going to the ocean can absorb carbon dioxide, all those different things that lead to uh, like uh, to the continuous measurement of carbon dioxide by killing. uh, in 1958, I think, that becomes the backbone of all climate science, record. Until till today, when we're talking about big data and these advanced statistics to figure out that's what's going on, with the climate of the Earth, right? So it's an interesting thing, history of climate change. I encourage you to actually to look at it, maybe read through it. Just understand that climate science is not a 5 or 10 year old field. It's there for some time, right? So this killing curve, it's the backbone, or you can say the most appreciated climate observation that kind of backbone of climate science that started in the 1950s by Killing as part of his postdoc, which continues till today, even after his expiration in 2005. So in 1958, when he started, the parts per million of carbon dioxide concentration, which is the main greenhouse gases, one of the major greenhouse gases, it was at 316 ppm, and in 2021 it reached to 416 ppm. So in such a short time, this carbon dioxide on the atmosphere, it just went to this much, right? And so as it's going up, uh, it's causing a lot of thing to the atmosphere, and it combined with the other cycles and all the interaction that we have on Earth. It leads to this complexity of this land atmosphere interactions and warming of the Earth. This is an overview of the different cycles of the Earth system, and among all these cycles, this carbon cycle is considered as one of the key cycles that we all are interested, and we really want to understand the state of it. So, I mean, let's maybe let's focus on the on this part on the tree on the left, right? So, tree, it gets the uh, the energy from the sun and does the photosynthesis, right? And when it does photosynthesis, it also like it decays, right? And it basically consumed by the animals and all, right? So that the decaying part, it goes into the into the earth, and over thousands of millions of years, some of them they forms into fossil fuel, right? And then and, the direct respiration from the plant and from the animals, they go back to the atmosphere, carbon dioxide, right? And but the problem is all that fossil fuel that got accumulated is discovered by us, by the humans, and because we became clever, and that led to the industrial revolution. And that industrial revolution, whatever actually did with the factories and cars, that started emitting additional carbon dioxide into the atmosphere, right? So what we did, we actually, there is on the left hand side, there is this natural CO cycle. On the right hand side, there is this basically our anthropogenic or the human induced carbon dioxide. So that uh, started becoming significant, and that started actually adding a lot more carbon to the atmosphere, and started causing imbalance into the overall greenhouse effect and warming of the earth, right? So there are other greenhouse gases such as methane, nitrous oxide, basically these hydrofluorocarbons, water vapor, aerosol, etc. Those also impact the earth warming, and their how they impact or how they drive the climate change and their degree are I mean different actually. So it is a plot that you can see. It tells you how uh, carbon dioxide emission change like over time, and how different sectors actually contributed of emission of this carbon dioxide. And you can see the coal, oil, gas, and basically those the anthropogenic like activities, they are major contributors, right? So Earth's climate is changing, and as it is changing, several evidence show us that it is causing changes in the temperature precipitation patterns, which are the two major parameters for climate change. That in turn increase the ocean temperature, sea level, and ocean acidity, etc. It is melting glaciers and sea ice. Is changing the frequency, intensity, and duration of the extreme events, and shifts, causing shift in ecosystem characteristics, such as the length of the growing season, timing of flower blooms, and migration of birds, etc. And all these changes are causing buildup of greenhouse gases in the atmosphere, and they're warming the planet more and more. So uh, the importance of the greenhouse effect is that we trigger it, we contribute to it, but the effect itself impacts the earth, and it is more of a like a positive cycle. We increase the greenhouse gases, it does something to the earth, it basically does some changes, some degradation, and that again increases greenhouse gases. So overall, it's a really bad cycle that we're kind of stuck in here. um, so as I said, there are definite specific indicators of how weather and climate has been changing. And so on the left hand side, you can see the global temperature change in the last 50 years, and you can see how most of these areas are actually warming up. right? It's some of the areas that you see, uh, like in the Mongolian area, Mongolian plateau type of areas, and basically up in the Arctic, they're getting lot warmer, right? And on the right hand figure, you can see human and natural drivers together. They coincide really well with the observed temperature. So that is also an indication that like what we are doing is directly contributing to the global surface temperature increase. Uh, so we do have direct measurement of temperature from basically from 1950s onward. From that killing like precipitative like killing basically not sorry, not killing is CO2. We have temperature measurements from about late 1900 because of all these, like different like factories, in Assam with Tigar just used it. So basically they realized that, it's important to like measure this temperature. So we have from the late 1900, we have this direct temperature measurement. Before that, we do indirect temperature measurement through isotopic, measurements, and like doing some isotopic analysis basically to understand what the temperature might have been, in the atmosphere. So, in using some ISO data, we can go back thousands of years. So, kind of, recreating that this paleoclimate. So again, there are some other observations. Like tree cover is like going down. It's warming again, and then the mean temperature is basically changing like dramatically in here, right? So all these things, I mean, what all these things are causing, as I said, greenhouse effect does something to us, and in return, it does something back, right? So it's causing a lot of changes, on the Earth like surface in terms of increase in temperature, basically a rapid temperature increase, what we call the heat waves, sudden like a lot of rain in some places causing flash flood, like basically flooding, maybe continuous, but flash flood, in some areas is seeing drought, right? And because of all these things, like some diseases are coming, into and it's causing a lot of destruction into the agriculture, which is again, what is the impact of it when you lose agriculture? It stress out the overall food chain, right? Uh, so these are important thing to worry about as part of our climate change consequences, because it does impact us directly, right? So when you talk about the major things that we really need to worry about, we need to worry about extreme weather conditions, which is basically increased frequency and pattern of precipitation, floods, storm, etc. Droughts with a rising temperature and changing precipitation patterns. And droughts are in some areas droughts are going to increase. Ocean, sea levels, they are actually going up because of the melting of glaciers, like warming up the temperature. Ocean is acidifying, and all these things, all these increase in temperature, change in humidity, precipitation, etc. They're having a direct impact on the overall health, human health, because it leads to a lot of like, viral like infections, new diseases are coming, and it's a one actually important area of research right now. How like old viruses trapped in the glaciers, basically very old ice, they're getting released, and like those viruses are coming out, and basically there are some new diseases which sometimes it comes out. I mean, people really don't know, how to treat them. So just old viruses, coming back out, right? So it's just happening. I mean, into the future, what is the degree of it? I guess we don't quite know, right? So now, having said that, all these, it's basically a lot of things are happening on Earth, right? And we kind of know what's happening and what is going to happen because we also have climate models. So we need to understand these things a little better so that we can predict, we can model these things into the next in the future. It's kind of running out of time, anyways. So for this, we need a lot of data. We need observational data. We need data generated, from computer models, right? So that's this focus that started maybe about 15 years ago. 15. That is when about 15 years ago it started like that, right? So we need to have a lot more data. But and then generate sort of like new and high resolution model so that you can capture or predict the future better, right? But all these, what it led to a huge amount of data being generated, right? As you can see, it started around 2010, right? So I started around actually, yeah, in 2010. I started my PhD in 2006, and at that point, when you think about when you talk about data, I mean, my PhD project was very, I mean, it was a renowned project because the data set I developed in the Arctic, it's a hyperspectral data set. It is the largest one anyone has ever developed. So we had a really crazy infrastructure that we developed and used to study some simulated climate change, right? That was kind of the beginning of all this stuff. But after that, it just went crazy, right? And I mean, what it created, suddenly we got a lot of data. We have some methods that we use, and because there are more data, we can't really handle it efficiently, right? So the next thing is how to develop tools to process these data sets, right? Then the analytical methods, of course statistics, and then this data science came in place, and can we even use this stuff, right? And then developing computer models, basically bringing in very powerful computers, to model these phenomena at a much higher spatial and temporal resolution, right? If it was 100 kilometer, spatial resolution before, now people wanted it to 1 kilometer, so that we can at least do something with the data. So all these things, this creates this data challenge for the 21st century. We are getting better at it now. We are kind of, at least, we are kind of beyond a shock point, thinking that, hey, I mean, I guess we are beyond that point where you can say we at least know what to do with it. Not quite what to do with it, but we at least know, I mean, how to handle it, you can say, right? So we're getting the hang of it. But I mean, we have a long way to go, in climate change. But again, the problems are becoming bigger and bigger. So it's a race, it's how fast you can go, how soon you can develop these solutions, how soon you can develop some basically predictive tools and models. So it's a scary time, but it's also a very exciting time to be in this research, because the field demands a lot of solutions to be developed using data, right? So in the last these few slides, I wanted to give you a flavor of how it started, right? As I said, that 2000, when I started in 2006, right? How we thought about this really big, experimental setup to generate a lot of data. And then I'll just give you kind of a glimpse of what we can do using a lot of satellite data, right? And then maybe I'll just end up just talking about data science, and then maybe what it can do about it. But again, I'm not venturing into data science into this stuff. So the first thing was, I just wanted to actually introduce you to one interesting domain, that I've been working on it since 2006, right? So it's a very typical, like a very interesting landscape called a permafrost landscape. So what it happens, I mean, look at this map over here, right, on the left hand side, and you see this gray area. This is basically in the Arctic Circle area, and inside whatever that blue, like that this color stuff that you see in here, those are your dead permafrost areas. The blue stuff is just lake, right? So it's not permafrost. But over here, you can on the left hand side here, you can see this is the Himalayas, right? The Himalayas is there. It's a very interesting thing because Himalayas also have this permafrost. Now the question is, what is permafrost? Right? Permafrost is any landscape or any ground that stays frozen for 2 years or more. It's not artificially frozen because that the area is so cold that it just gets frozen throughout the year, right? And these are let me see, go from here. Yeah, so you can see the figure on the top right. So that's permafrost. Basically, it's kind of splitting apart. It's all frozen soil out there, and that soil has a lot of organic carbon stuck in there, right? And in here, you can see this cross section of it. You can see it's the top layer. It's like the fields I can probably see in Assam or Northeast, right? It is just grass on top of it. But the funny thing is, in those landscape, that is the only vegetation that you see because landscape is so northernmost that they only get just a few months, maybe 2 to 3 months of snow-free time, and the only thing they can grow in there is just this sort of like grass, it's called tundra, right? And there's a very thin layer of soil on top that you get it during the summertime when it gets warmer, and below this, it's frozen this permafrost, which got frozen and accumulated over thousands and millions of years. What the problem is, even though this landscape is not as much, you can say around 9% of the world's land cover. It's just about 1% of plant carbon because there's not much plant in there. The soil carbon it has in there is about 30%, and they are all frozen. So when it is frozen, the point is, with the warming, what is going on? Those frozen areas, they're actually warming up and they're starting to collapse because it is ice, right? I mean, like it's basically frozen, and you got some ice in between. Like it's like frozen. If you get a bunch of frozen stuff in the freezer, you take it out to a warm place, it's going to thaw out. That's exactly what's happening. But the problem is when it is happening, it's also releasing a lot of greenhouse gases because a lot of microwave activity is happening. Normally, what it happens, and then so that becoming like hotbed of greenhouse gases coming out of those areas. That's warming the atmosphere a lot more, and it's basically a positive like cascading effect. It's warming the atmosphere. The atmosphere is warming it more, so it's a bit of a disaster actually out there. What's going on, right? And so when it happens, these big areas collapses, as you can see, right? It's actually there is no scale in here, but it's pretty big. If you have somebody standing in here, this is pretty big rock. That's all I'm going to say. This one, right? If you have somebody standing by it, this is probably going to be, as big as this rock, right? So these big areas just collapse, right? And then they release a lot of greenhouse gases, basically, if you have buildings are going to collapse and all. So we need to actually, this is what we, all this data-driven kind of stuff, it starts on that. We don't have data on that. What kind of greenhouse gases, whatever, happens in there. I mean, we do have data, like a lot of people are generating now, but at one point it was scarce. So you have to go out to the field and you have to generate a lot of data by ourselves. And we have to keep going back and back and back and again, right? So that we generate this sort of data set. And then we use the data set to model something about how this ecosystem is changing or the state of this world is changing, right? And we install sensors which gives us the data on temperature and all, right? Uh, so in here, you can see this sensor out here. This is actually a sensor. It's a handheld remote sensing sensor. We can use that sensor to understand, how this landscape or the vegetation, their state and how they are changing, because you can compute different numbers from that signal, which tells us different types of vegetation condition, how vegetation is getting staged out, how it's greening up, water content, etc., etc. And we can do a lot of other things. And I mean, why it actually helps if we can use remote sensing, we can use this data from aircraft and like satellite and all, from other sensors. We can like do monitoring for a much larger areas, and that gives us a lot of like much bigger coverage, and also it saves us a lot of field work and like money, right? So along this line, I'll actually try to like go a little faster on this. So this is an experiment that we did where we installed like this large infrastructure. This is about 300 meters long. So you got basically 3 of those. It's about like a kilometer, you can say. So and then we ran a robot on top of it, so which collected at every meter automatically it collected reflectance data, and using that we could do such as how the season is growing, right? And these different scenarios that you see, this is like the snow is just breaking up, then it's basically flooded, right? And it's greening up. All those things actually you can capture using the remote sensing signal, right? And then we can see how this season is changing, right? And so going along the line, so that's something that we did, and we actually asked questions about how changing hydrology is, this affects this overall this purpose landscape, and a lot of data generated, and we developed a lot of software tools and all, right? So that was again, as I said, that was the beginning of this like the data era, right? And then we wanted to do it at a much larger scale, at a northern hemisphere scale. So in the northern hemisphere, how you do it? We had to do some spatial analytics, and we had to create some spatial model using existing global data set, right? Existing global data set, and then we modeled it, and we actually said that about 25% of the entire permafrost landscape is seeing degradation, and we also estimated like how much of the carbon is in those areas, right? So as you can see, this is a bit of a change from the ground-based data generation and doing study on the ground into spatial analytics at the global scale. And then, so I wanted to actually come back to a regional scale, which is what we did with ISRO. So we worked on some basically coastal processes, dynamic coastal processes, because coast is very important for India. It creates a lot of economic like resources and economic resources, and also like basically like a resource for the communities that are living on it, right? So we wanted to know, like the first thing is, how do you know how this coast is changing, right? What is the state of this coast, and how do you actually study the changes of this coast at much smaller like location. So we can't really like go and do the field studies, but we have to do the field studies as well, because you want to know it like like a little better. So first we wanted to have a synoptic view. We used like about 50 years of satellite data, and then we did a train analysis to understand how these coastal areas are changing. Then we found 5 hotspots that these areas are changing a lot. Then we picked up one area in Orissa, and then we processed 5 decades of data, right? It's a satellite called Landsat, and we processed them. Then we basically generated monthly, seasonal, and yearly data, right? Then we drew conclusion of what is the state of the vegetation, in those areas. So we found that vegetation is it showed a much like higher increase in vegetation in one area, right? And there, of course, other work on the water quality and all this stuff, which I'm not showing in here. Uh, so so basically, after processing this much data, we found out we were able to identify the areas where there are a lot of increase in the vegetation. And when we did a field work, we saw those areas were infested, with in these invasive species. So the next thing is to like how do you actually like predict the dynamics of these species into the future, and can we actually come up with some solution uh, for the management of this species that the authority who is handling this lake, the Chilika Lake, can use, right? So that's another example of how you can use a lot of data to actually assess an ecosystem, right? So again, kind of, going back to what I said, we are generating a lot of data, right? So it's causing us this problem of climate data challenges in the 21st century, right? But good thing is because computers became much like stronger, computers became much you can say larger, and algorithms, there like better algorithms are being developed. There is this artificial intelligence and machine learning, like overall AIML or like deep learning. This area is coming out very strong because there's a lot of people working on it right now, right? Because there is a strong value of these work into the business world, and that means like the tools are being developed like very nicely. The other question is how do you use these aspect of it, right, into our work. So that's something that we are interested. We are starting to work on it actually, and more and more people are starting to work on these. We did advanced statistics to see if we can say do stuff which the traditional method cannot do. For example, when you have satellite data, right? Satellite data has its limitation about pixel size, right? Uh, of course, you get satellite which has much finer pixels, but those are very expensive because those are commercial satellites. Then the question is, can you actually, take a coarser satellite data, and can you generate finer resolution data from there using something like generative adversarial network type of thing? And can you recreate some data set which can be usable to find finer scale information? I'm just giving an example, right? And say in Assam we have floods all the time, right? So can we actually come up with models which can predict the flood with accuracy? Easier to say than done because then we also have to worry about ground truthing data and all, right? So that's an area that you can I think it has a lot of potential. And then when it comes to like overall data science landscape, it's the infrastructure, right? Uh, this analytics and machine intelligence and applications, right? That's what we talk about, and it's supported by huge open source like infrastructure tools, right? And so, I mean, why I'm saying it? What is data? Because it's very common, right? I mean, we all know what is data and all, right? But I thought it would be good to kind of pitch this to the community with the assumption that this community has a lot of students, a lot of researchers from the engineering background, right? So the data for a lot of you might mean that's customer data. I mean, I'm just giving an example, right? Because something that is useful, to the business world, right? But to me, data is just data. Like the slide that I'm showing you here, it is data, right? So it's something, basically some information in some qualitative or quantitative form, right? So this is, these are like remote sensing pictures that you see, these colorful ones on the top left in here, right? I'm showing the lake, right? Uh, the quality of the water in some qualitative form, right? And also how these rivers, they actually like, spewing out a lot of mud into sedimentation into the ocean, right? That's a representation of data. In here, on the top right, it is again, it's a fixed satellite image in there, right? It shows two neighborhoods. I think it's in an African country. Two neighborhoods divided by a road, right? On the left, it's a slum. On the right, it's a like well-to-do community. Right below here, it is a image from Hyderabad. It shows the traffic condition. On the left, in here, history of India. It's a wiki page. It's like basically it's some data about history of India. Right. These are all different data. They are all in different forms, but at the end of the day, they are just data. Right. So, I mean, why I want to say that because when you are working with data, mm, you shouldn't be how do I say? You shouldn't be like worried in what form you're getting the data, or like what kind of data you're getting, because at the end the data is something that's going to help you to solve a problem. So when you're working on like some data related problem, the first thing should be the problem definition. How do you define the data, and then then basically like define the problem, and then bring the knowledge of all these different fields, like computer science, mathematics, like statistics, data processing, machine learning, and then some domain expertise that like either you get it for somebody or try to develop it, and then basically we like mix it all, right? And that's your data science, and then you try to solve the problem, right? So again, maybe I shouldn't go through all this. Like this is all like it's the boom of basically data, like over time, and then yeah. So uh, the point is, like in our field, it's in our field actually, it's a data tsunami right now. Like, are you ready with all your tools and with your attitude? That is what it matters, right? And these are some very, very important report that came out just recently, IPCC 6 assessment report. I think that the main report is going to come this year, and then impact, adaptation, and vulnerability. And all these reports are showing how badly India is going to be impacted by climate change. So, and how many people are going to be impacted, right? So now the question is, like the country itself and the globe, like in the global scenario in general, need to change the attitude now, right? It's not that only scientists work on climate change; it's everybody needs to work on climate change, because the problem is rather big, right? There's so many things to do in here, right? So if you think about how we can generate a lot of research are in here to work on climate problems. So this is again, it's a very, very humble effort from our side that we are building up a small community of we call it Community Climate Lab. Check it out. cclindia.org. That's the web page. India. So we, I mean, bring in people, young people, whoever wants to, like do some research, get excited about the climate and environmental field, and want to actually do something about it. Also, learn about research and uh, like do something. But again, it's an open source. It's like if people are just getting together. But when it comes to work, we are actually serious. I mean, we don't just hang out. We work on projects, and we develop solution, and things are going just great. So check it out and see if it's something that interests you. Reach out to me. We have a LinkedIn page as well. So yeah, and we have planned to actually like have like more talks and activities into this 2022-23. Actually, we just officially launched. I mean, I got launched actually late last year, right? So yeah, connect with me. I mean, I always like to talk to people, young people who are interested, to talk about basically exciting stuff, research and all, right? Active in LinkedIn. So yeah, having said that, thank you very much. It's really really nice to be able to talk to people in here. And yeah, if you have any questions, I mean, I attempt to actually answer now, maybe in the live, and if not, you can even talk later. I mean, as I said, active LinkedIn. We have this community climate lab. So yeah, I mean, just be excited. Stay excited. Think about all the stuff that you can do for some meaningful work in climate and environmental science, right? And let's build a sustainable future together, right? Yeah. So thank you very much.
Thank you so much, sir, for this really interesting and insightful talk. I think for all of us watching, we have had an overall idea that climate change is happening, and more recently with all these droughts and floods, even bushfires happening, I think people are taking more notice to it. But I feel with this talk, it was more of a technical, at least to a certain extent, overview of how possibly we can tackle climate change. As you said, using remote sensing and data, maybe we can predict future patterns in climate change.
Yeah, yeah,
So
yeah.
yeah,
Hope so. Yeah. It was just a very humble effort to give an introduction. There's so many things to do in here.
yes, sir. And it was also good to know, so that you were one of the pioneers in database approaches to climate, as you said during your PhD days.
Right, right. Yeah.
So yeah, that's good to know. And yeah, I think with that we can take a few questions.
All right.
I have one question here with me, which we got in our form that we rolled out
Okay.
before the
Okay.
live, and it is from Tasneem. She from the IT Sligo Institute, and she's asking how useful are data-driven models as compared to process-based models.
Hmm. That's a interesting question, because process-based model is something that we have always relied on because those are physics-based models, right? I mean, we know when it comes to process-based models, we actually know how the model is working. We know the mechanism, right? Uh, when it comes to data-driven models, this is statistics, right? So when you do statistics, you actually process data, and then it shows you something. I mean, how do you know whether it's right or wrong, right? But there is a new but very strong effort or interest in developing data-driven model. So I don't really, and I'm very hopeful because hopefully these data-driven models can give us insights that maybe some of the system process models cannot give. But I don't think I can really make a comparison now, which is better, process models or data-driven models. Process models I know because it's, I guess we know how process models work because it, based on physics, right? Based on equations. Data-driven is just crunching data. So I guess it all going to depend on how better the tools become, in deep learning, right? So, not a straightforward answer to that.
I see. Thank you, sir.
Yeah, definitely.
I think other than that, I think we have on our YouTube chat. I see Shakuntala ma'am. She's saying that it's a very important topic in today's day and age, thanks to Dr. Goswami. So
Thank you, thank you.
she's nice complimenting you, sir. And I think I had one. I mean, just it's not like a question as such, but I just wanted to know little bit more about this Indian permafrost study, so
Haha,
that is
haha.
there at Svalbard. Can you just tell
Yeah.
us something
So,
about?
yeah. So it's a. I mean, you know, why do you even go to Svalbard? all the way from here to do some study, right? Uh, so there is something, that's the first question I guess anyone should ask. I mean, why is waste so much money? Go to all the way to Svalbard and do some study. Uh, there's something this thing called teleconnection. So how these these say Hadley pattern, you can say this airflow, right? That's happening, or that kind of goes around, like the Earth. How warming of one area can lead to some changes into other areas, right? So that's what I think one of the things why we wanted to go and study the Arctic, right? Uh, so it's and then the thing is, for me, like when it comes to permafrost, uh, in permafrost studies in the Himalayas, it's very, 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 very scarce, right? When I came here in 2016, like when I started in ISRO, when I said the word permafrost, nobody heard about the word permafrost, right? And now there are some people, and then when I went, like basically presented in NCPOR, again it was like, okay, it's kind of what is permafrost, right? So now there are several people, they are actually working on it, like projects got funded from by the ministries, so there are work going on in the Himalayas, but again this is very, very like nascent stage right now, right? So why I wanted to work in the Svalbard, because Svalbard landscape is very similar to the Himalayas, right? Now we have ongoing work in Ladakh. So, and then we have this very nice access, like field access, from the Indian Arctic expedition to go and do some studies in there, right? So that's why I generated some data. So goal was to actually continue that, but I don't think I will be able to continue it now, because I'm at a different institute and focusing on the entire entirely on India right now. But that was kind of the thing, like you study an area which resembles another area. To go and do the study in the Himalayas, it takes a lot of effort, right? Because you don't have proper field access now. That's why we studied there. But now we hopefully like we start working in the Ladakh area a little more, because as more people are going there, there better access, So that's why we started on that.
Okay, sir. So basically, insights from Svalbard will help us to deal with permafrost soil in the Himalayas.
You can say that. You can say.
Okay, sir. So I think we have another question from YouTube chat. Shakuntala ma'am is asking what are the United Nations initiatives in NYC? Any contacts in USA through your work?
NYC, New York City, or
I think ma'am is mentioning probably New York City.
can I ask them to send me that question directly to my email or something? That will be better actually.
Okay, probably we can patch
Right.
patch that.
Yeah. Yeah.
Sure. And I think ma'am has also said because of climate change, we are getting bomb cyclone slash snow thunderstorm in New Jersey.
Yeah, maybe I don't know.
Yeah, I think she has mentioned that point.
Okay.
Other than that, I think we don't have any further questions. Maybe Shishi sir, if you can confirm.
Yeah. I think we don't have any questions from sir. It was an excellent talk actually. Like, and we got some brief overview of what exactly is going on and what we can do. So I have one question. Like,
Yeah.
as you mentioned, like we are generating a huge amount of data. Like in every second, actually, we are generating data from
Yes.
different sensors. Okay,
Yes.
from sensor networks. Now, if we want to take something, for example, I am a student, so I got some amount of data. Like, where we will process the data, because these are a very huge amount of data. For processing those data will be required some kind of GPU or other compute power. So
Yeah.
how that thing like CCL like want to handle from your
You're talking. Are you directing the question to CCL or?
in terms of maybe CCL or kind of
Okay, I mean, normally I can maybe say it in like in two different ways. The first thing is let's talk in general. How do you handle the data, right?
Yeah, yeah.
So that's it's a lot of the data providers these days. They are also giving some sort of access to cloud data processing, right? Google Colab is there, right? Then NASA they gives some gateways where you can actually, instead of downloading the data, you can process the data there. You can download the result, right? And then in European Space Agency also, basically they are providing those gateways now, where it's you can download the result after you process it, right? Or you can like basically subset something, like create some sort of a, like final CSV file on a CDF, and you can get the data out, right? So they are providing this. If your data is big enough, like so big that you have to find some basically computing infrastructure, right? So, but for students to learn, I don't think they really need that, because whatever like Google Colab is giving, it's giving fairly like good, I guess, infrastructure for initial data processing, and then yeah, and then basically, if you have access to a good computer, that basically work on it, right? I mean, I guess the idea would be to be clever on how you want to, like process the data to what extent you want to process the data on the cloud, and what you want to get to your hands so that you can handle the data, right?
Okay.
So that's going to be the idea. And in CCL, we are doing the same thing, actually.
Okay. Because from the student perspective, actually, this is an important question because
it's very important, very important.
Yeah. Sir, second question is that like.
Okay, sorry. One more thing.
Okay.
If I can stop it? Sorry, I forgot about one big tool. It's called Google Earth Engine. Google Earth Engine, and then Microsoft has something called Planetary Computers. Similar thing. They have started just now Google Earth Engine in India for a long time. You can process all the satellite data and a bunch of climate data in there, and that's free, right? It's cloud computing basically, and so that helps us a lot. That's what I'm saying. Yeah.
Oh, okay, sir. Thanks for the answer, sir. Second question is that like when we build some kind of predictive models, for example, just I'm giving one example, like we are going to predict like whether like just tsunami will come or not. Just I'm giving a rough.
Sure.
May not be relevant that, but
right.
Just I'm giving that idea. Like we are building some kind of predictive model based on some data from sensor data. Now there are two things. Like one thing is that how confident my prediction is. Like whatever the prediction I am giving, how confident is. Like how uncertain or how certain that is. Like whatever the prediction I'm giving. And second thing is that explainability. Like why I am giving that prediction. So how like climate this kind of research is, because this is more important related to climate research. So how?
I mean, explainable AI. That is something very important that's coming out. It is an important area. I don't think I can really answer that question because I don't. I read about it. I still need to know a lot about how to work on it, right? So I mean, again, that's my inability. I cannot really answer it. And when it comes to your knowing what you are producing is correct or not, right? That is when you need to have ground truth data. Right. Again, you might ask me, okay, how can I basically have ground truth data, to predict a cyclone in the future, right? So when you are going to develop the model, right, as you have all this data from the past, right, for the last 10 years or say, right? So you develop the model maybe from year 0 to 5, right? Apply the model in 5 to 10. I'm talking about for the last 10 years, right?
Okay.
And then you will know, because those are already things that happen, right? Then you will know whether your model is working or not, right? Then you can say, because I tested it out, it seems to be working fine, so maybe I can do some prediction into the future. That's the only way you can do.
Yeah. Okay. Yeah. Fine. Thank you. Yeah. So in that situation, actually, we call something like concept drift or data drift. For example, whatever the data we use for building our model, suddenly something happened, and suddenly that whatever the data distribution totally changed. So whatever the model we build may not be like accurate for that kind of data distribution, because
But
it's
that's again, that's an outlier, right? That you're. I think what you're saying is an outlier. Uh, I'm just going to reflect on what you said. Right? You talked about maybe like a cyclone or maybe like a disaster, some sort of event, right?
yeah.
That is some sort of an outlier, correct? So I was thinking more about how do you capture an outlier using the data that you have for the last 10 years, and maybe use few years of data to build a model, and then use the rest of the years to as a train and test kind of thing, right? So that's
Okay.
what I was trying to say on this.
Okay. Okay. Yeah.
Yeah.
Thank you. I think, sir, maybe we can stop. Like we can
All right. Yeah. Yeah.
wrap
Yeah.
up. Yeah, our
Yeah.
session. Yeah. We can. We can. Yeah.
Yes, sir, sure. So, yeah, I would just like to say, first of all, I want to thank Santanu sir once again for this
Thank
wonderful
you.
talk, and thank you everyone who has been with us today in the YouTube as well. So, yeah, with that, we can I think close the live stream.
Thank you very much. It's really, really pleasure giving a talk.